Hey everyone, today let's learn about naive-Bayes classifier, which is one of the classification algorithms in machine learning, and we will go through the implementation of it. In this video, we will first see what is naive-Bayes classifier, then with an example of spam email classifier, and finally wind up with a demo. Naive-Bayes classifier. In machine learning, among supervised and unsupervised algorithms, naive-Bayes classifier is one of the simplest supervised learning algorithms. It is fast, accurate and reliable algorithm on large datasets. Naive-Bayes is a classification technique based on Bayes theorem. This equation expresses the Bayes theorem in the language of probability. Scikit-learn, that is Python library, which will help you to build a naive-Bayes model in Python. Mainly, there are three types of naive-Bayes model under scikit-learn library. Type 1 is the Gaussian. It is used in classification and it assumes the features follow a normal distribution. Type 2 is the multinomial. It is used for discrete counts. Third type is the Bernoulli. It is useful if your feature vectors are binary, that is zeros and ones. For more details on naive-Bayes classifier, check out my article through the link in the description. Some of the real-world examples are to mark an email as spam or not spam, to classify a news article about technology, political or sports, to check a piece of text expressing positive emotions or negative emotions. Let's move on to the example of spam email detection using naive-Bayes classifier. Currently, spam email has become a very serious problem. The spam box in your Gmail account is the best example for this. This example involves classifying an email as spam or non-spam using multinomial naive-Bayes. Now let's continue with the demo. Here I am using a spam email dataset from Kaggle, which consists of spam and ham mails. Usually the spam emails consist of words like free, winner, etc. Now let's train our model using this dataset. This is Jupyter Notebook. Let's start by importing these libraries. We'll import pandas as PD, and from sklearn we'll import the train test split, count vectorizer and the multinomial naive-Bayes. Using pandas, let's read our dataset. We'll pass our dataset to the readExcel function, and using head function we'll get the first 5 rows of our data frame. You can see our data frame here. Applying lambda function to the category column will assign 1 for the spam mails and 0 for the ham mails. As you can see, for the spam mail it is 1 and for the ham mail it is 0. Now we'll split our dataset into random train and test subsets using the train test split function. Here I am passing the message and spam column from my data frame. And test size is equal to 0.2, that means my training set is 80% and test set is 20%. Using the count vectorizer function, we'll convert the collection of text mails to a matrix of token counts. Here we'll pass the xtrain values and transform it into the matrix. Finally, the xtrain count will have the count matrix and then we'll convert it to an array. Now you can see that we got an array. This array is nothing but the count of each word in a single message. We'll create a multinomial model and train it using the fit function. We'll pass the xtrain count which we obtained here and the ytrain. Now let's train this. As you can see, it was successful. Now let's predict some sample email. I have given 2 emails in a list called emails. Using count vectorizer, I have transformed the emails to token counts. Let's run this. As you can see, it predicted 0 for the first mail, that is non-spam, and 1 for the second mail, that is the spam mail. Let's see the score of our model. Here I am converting the xtest to the string and then transforming it using the count vectorizer function. This is to calculate the score. As you can see, it is 0.98, that is 98% efficient. In this way, the spam and non-spam emails are classified using naive-Bayes classifier. In this video, we looked at one of the supervised machine learning algorithm called naive-Bayes, which is mainly used for classification. Congrats! If you have thoroughly watched and understood this concept, you have already taken your first step to master this algorithm. From here, all you need is practice. Further, I would suggest you to focus more on other examples too. If you find this video helpful, Please like and share your opinions and doubts in the comment section below. Thank you.